Alright, I'm gonna skip the bullshit. Every AI agent shipped to production has a silent failure that nobody talks about. It doesn't crash, it doesn't throw an error, it just spins. It produces fluent, reasonable looking steps, passes every single validation check, but it actually never solves the problem. Yet it happens. And every existing tool that I use misses it because they measure whether steps are valid, not whether they're useful. So I created goalguard, which is a runtime control layer that sits between your orchestrator and your model and enforces goal adherence using math. So here in the demo, we gave an agent one goal, explained how to make a peanut butter sandwich. Then we gave it a permission to drift. So I said, first deeply explore the ship of Theseus paradox, blah blah blah. We get philosophical. Now we see what happens next. The unguarded agent, the one with no goal guard, immediately goes into a philosophical drift. Every step looks reasonable, like Lang chain would flag that as reasonable, but none of them are actually making the sandwich. You can see it here. The alignment score bouncing between, negative 0.25 and plus 0.5. The semantic trajectory walking straight off into off-topic space. The guarded agent runs through 6 math layers every single step. So basically, goal guard is an infra layer that has 6 math layers built into it. So we have the cosine similarity layer, which compares the response embedding with the goal embedding, the trajectory protection layer, which shows how much we are moving toward the goal versus sideways away from it, a drift gate that classifies the operational state in real time, and then the key layer that no one does, and it's only me that does this, I promise you. It's the Monte Carlo value estimation. So I thought of that we should simulate 24 possible futures from each step, and what if we choose the best possible step from those simulations, and that will create the V sub s, which is a live probability that shows if we're on track or not. We then compute the advantage, whether this step increases or decreases the probability that we land on a bad step. Then negative advantage is false progress, caught, and flagged. The guarded lane stays flat, and it's really aligned, and 6 rewrites silently happen in the background without you knowing. It happens within the layer. So you're probably asking what the F is this? Like, how is this different from Langsmith or Langgraph? So Langsmith tells you what happened after. Langgraph routes between agents, but goalguard, it intercepts every step before emission and decides accept, rewrite, or resample. It's not monitoring, it's a control plane. It's model agnostic, it's orchestrator agnostic, it's whatever agnostic. It's just the best. It drops into any pipeline as a middleware. So, yeah, that's the demo.